We then worked with a company called Productive Machines. They provide a lot of optimization technology, so they do analysis on the material. We do cutting force trials. We do tap testing to measure the frequency the tool wants to resonate at. And they also take our NC code and they run it through their system, which generates an optimized output. So they're controlling the feed rate throughout the cut to ensure that we have a consistent level of force throughout the whole component. The end result is we have two features that are exactly the same. We have one program that runs at about 9.5 minutes and another program that runs at about 8.5 minutes. And that's exactly the same program. The only difference is one has been optimized.
Which is that's almost like a 10, 15, I can't do the maths in my head,
about
but like a 10,
saving.
10% saving.
Yeah.
Just by changing what did you actually change? What's the process? So you create the NC file for this side.
Yeah, and it's particularly interesting that we're using an adaptive clearing strategy. So we've used NX to generate an already quite efficient toolpath. What Productive Machines have done is they've looked at the cutting forces. So we have a 15 millimeter deep engagement and we have a consistent engagement throughout. But as you enter corners and you exit corners, you have an increase in your amount of engagement based on the angle of that engagement. So that increases your force or decreases your force as you come out of the cut. So they look at the overall force through the whole toolpath and then they pick a level and they increase your speeds to get up to that level or decrease so that you don't put undue stress on the component. They can also do optimization for non-cutting moves. So they know exactly when you've retracted away from the material and they can make it go to a G0 on the rapid transfers. So you can get a lot of a lot of time saving